for the session is Azure Service Fabric, where we will see how you can quickly develop and update microservices-based applications. Before we start, let me highlight a few housekeeping items. During the webinar, please feel free to post questions in the questions dialog, and we will try to answer as many as we can at the end. A presentation and recording of this session will be shared to you in next 24 to 48 hours. So with that, let me take this opportunity to introduce you to my colleague and today's session speaker, Mr. Viplav Sharma. Viplav brings over 12 plus of years of experience in the IT industry, and is a senior consultant at Winwire Technologies. He is part of pre-sales and delivery team and has been responsible for multiple client engagements and Winwire Technologies. So with that, I would like to turn it over to Viplav. Viplav, over to you.
Thank you, Noor. Thank you for the introduction. And a very warm greetings to everyone in the audience. Thank you for joining the session, and I hope that the next 30 minutes or so would be fruitful to all of you. Once again, my name is Viplav Sharma, and with that, we can get started. All right, so let's set the agenda for today's session. First up, we'll talk about microservices, how they have been very effective in solving the challenges that the IT organizations have been facing in the cloud-based world. We will then talk about Service Fabric, talk about what all features it provides to the developers and the administrators. We will take a deeper dive into Service Fabric as we look at the architecture and also at the benefits that we get out of Service Fabric. Towards the end of the session, we'll see a quick demo on how we create a Service Fabric application using Visual Studio. And at the end, we'll open the forum for any questions that you may have. Well, over the past few years, we all have witnessed a revolution of its kind where more and more organizations are moving their applications and infrastructure to cloud. And with the amount of flexibility that cloud offers them, it actually prompts them to aim for more and more to stay ahead of their competition. So basically, all companies want a high availability of services, pretty much 24/7 websites. The scalability of infrastructure has reached a new meaning where the instances of VMs could go anywhere from a few to thousands, depending on the needs. And we all live in an agile world which drives a lot of changes in the applications, and nobody wants to wait for a small change to take 6 months to get deployed to the production environment. The overall goal, obviously, is to reduce the costs by improving the resource utilization. While all of this is technically possible in a cloud-based application, it presents a huge challenge to the IT service organizations who are trying to build and maintain those applications. We'll take a look at why it is so difficult with using the traditional approaches that we've been using so far. Microservices is a term that has become very popular over the last couple of years. And it's essentially a design approach that you can use to develop an application not as a unit, not as a single process, but as a set of small services, small independent processes that encapsulate a piece of functionality in that application. And using this approach, these services also communicate within themselves, between themselves, using lightweight mechanisms. One of the key benefits of using this approach is that these services can be independently deployed rather than deploying the entire application. And for developers, it's also great because you could use different programming languages to build microservices. You could use various kinds of data storage technologies to store your data. So there is no restriction around the frameworks and the languages. In order to better understand the benefit of microservices, let's take a look at how we typically use to build our applications. We used to have, we still have 3 layers where we have a web front, we have a business logic layer, and a database layer, data layer. So while the application is divided into 3 different layers, it is still very much one process. Because if you need to make a small change anywhere in the application, in any of the layers, it will take you to rebuild the entire application and redeploy it. And that's why it's called a monolithic design. Another issue with this approach is, let's say you have a requirement of scaling out one small area of a large application. So you cannot just scale out a small piece, but you have to scale out the entire application. Effectively, you are wasting some resources, which obviously adds up to the cost for the business. So let's see how microservices solves these challenges. As you can see in the diagram, we still continue to have 3 layers, but each of those layers or components are split into multiple services. Web layer has one service for authentication, one for the content. Business logic has a component for service for order management and reporting, and so on and so forth. So in this case, let's say if the business requests a couple of reports to be fixed, or there are some issues in the reporting service, all you need to do is make the changes, test them, and deploy the reporting service without actually touching any of the other services. In another scenario, if let's say a very common scenario, your e-commerce website is expecting a lot of traffic on a Black Friday sale, so your usage analytics piece needs to be scaled out. You don't really have to scale out the reporting service because let's say it doesn't have that much audience. So you will be saving a lot of money around, or the business will still be saving a lot of money around scaling of the infrastructure. Well, microservices are of 2 types, stateless and stateful. As the name suggests, stateless microservices do not maintain state beyond request and response. So they have to rely on external storage to maintain this state. Like for example, in the left diagram, you can see the compute relies on another storage mechanism, which could be Azure, SQL, or anything for the storage. And in order to keep the application reliable, it has to depend on a queuing mechanism. And in order to keep the latency levels low, it has to have cache as well. So as you can see on the left, there are a lot of moving parts, and you need to manage them, and you need to maintain the consistency of the state. Whereas in the stateful microservices, the application state lies in the compute tier itself. In this example, you still have a stateless web, but you have a stateful compute. What that means is it immediately creates an impact by having a low latency levels, and the scaling is much more efficient, and of course there are lesser moving parts. So when building microservices, you need to make that decision whether you need a stateless service or a stateful microservice depending on your requirement. Now that we have a background on microservices, let's talk about the main topic of today's session. Well, microservices are a great solution to the problems that we discussed in the first slide. But at the end of the day, you have to manage the various aspects around microservices like scalability or availability, replication, failover mechanisms, and so on and so forth. So this is where the Service Fabric comes into play. Service Fabric is a distributed systems platform that allows you to focus on your regular application development issues, which may be more important to you, and makes it simple for you to manage your microservices-based application. And one of the key features of Service Fabric is that it allows you to deploy the application to either a Windows Server machine or a Linux machine. And they can reside on either Azure or even private cloud or even hosted clouds like Amazon. So you could potentially deploy your application anywhere. And for developers, one of the great features is that it gives you a development environment which is identical to the production environment. What that means is it creates a local cluster for you on your machine, and it's also called a data center on your machine. That's the term that has been used. What that ensures is that the code that you run on your local cluster will run the very same in the production cluster. And there are no emulators involved like we are used to using in other cloud-based services. All right, looking closer into Service Fabric, this is how the Service Fabric has been architected. It's essentially a bunch of subsystems that have been piled on top of each other. So at the bottom, we have the transport subsystem, which is responsible for secure point-to-point communication between the Service Fabric nodes and also between the nodes and the client. The federation subsystem that lies on top of it, it essentially unifies your nodes, the Service Fabric nodes, into one single entity, which is called a named cluster, and so that Service Fabric can consistently route the requests or even detect failures and manage them. The communication subsystem is responsible for the discovery of services, because at the end of the day, the services have to be discovered in the form of URLs. And then reliability subsystem makes sure that the service is reliable and available, and it does so by using replication and failover mechanisms. Hosting and activation is basically, it runs on each node of the cluster, and it's responsible for managing the application lifecycle. The management subsystem takes care of the overall management of the Service Fabric cluster, which includes the deployments, the upgrades, and any kind of health monitoring of the application. Testability subsystem, it's basically a facility to the developers who can actually test their code using simulated faults and stuff, so that they test the code before they actually deploy in production. Application model and the APIs are built on top of these systems. We will look at more closely at the application model in the subsequent slide, and we'll see how it is structured in Service Fabric. Okay, so for developers, what are the programming models that Service Fabric offers? There are three ways you can build a Service Fabric application. The first one is guest executable. And this essentially means that you already have an executable which you have built, and it could be written in any language, be it C, C++, or Java, or anything. And all you need to do is provide the executable, package it in the way Service Fabric wants to be, and Service Fabric will handle the orchestration or the execution of the executable once it is deployed into Service Fabric. Obviously, it does not benefit from the full set of Service Fabric features because it's not built on the Service Fabric platform. Reliable Services Framework you could use for writing services that integrate with the Service Fabric platform, and it gives you great control over the design of the application and the implementation choices. You could very well even host some other framework like ASP.NET using Reliable Services. Reliable Services can be stateless or stateful, as we learned in the previous slides. Reliable Actors is another model which is actually built on top of Reliable Services. However, it implements the actor design pattern. So as we all know, or if we don't know, we could actually read about it, but actor design pattern splits your application into number of actors, which is nothing but independent units of compute and logic and state, and they run as single-threaded units. Reliable Actors framework provides a built-in communication and state management for actors. Let's take a look at the application model. An application is composed of one or more services, and each service has a code package, configuration package, and a data package. So code package is nothing but your executable, and you specify the entry point or a setup entry point. Config package contains the configuration settings that you may want to use for the service. And data package is just any files that you want to use to support your service. So let's quickly go through what you need to do when you have to build a Service Fabric app. First and foremost, you need to select a programming model, right? And then you need to decide whether your services will be stateful or stateless, depending on requirements. If it is stateless, you need to decide where your state will be stored externally. You then build the services, depending on which model you pick. And very importantly, you need to set up the communication between the services. You need to decide the protocol, which is typically HTTP, but could be any protocol of your choice. You need to decide how Service Fabric will discover services, how it will resolve the requests. And then you describe each service and each application. There is one application composed of multiple services, so you describe each service and the application. How you do it is in a service manifest file or an application manifest file that we will take a look at in this next slide. Once you're done with building and describing, you package the application, making sure that all the files are in the right folders. Then you deploy the application to your local cluster. As we discussed earlier, Service Fabric provides you your own local cluster, which is very similar to the production cluster. And you could deploy this using Visual Studio or even PowerShell commands. You can monitor your application via Service Fabric Explorer. If we get time towards the end, I'll show you how a Service Fabric Explorer looks like. And then you can actually debug the application in Visual Studio. At the end, you can deploy it to the production cluster. This is a sample service manifest file. As you can see at the top, it gives the name and the version of the service. Then it specifies the type of the service, whether it is stateless or stateful. It also has the code package, which basically has the executable here and this setup entry point and the entry point. config package as discussed earlier, and the data package. It also contains the endpoints of the service, which is not in this screenshot, but that is also something you can configure in a service manifest file. Applications manifest again has a name of the application, the type of the application, what all services does it contain. It's mentioned in the service manifest import section. It also specifies the default service, basically when the application is launched, which is the first service that should execute. So to summarize, apart from making your life simple in terms of management of your service application, Service Fabric allows you to create or build applications that are hyper scalable, highly available and reliable, using the replication mechanism it uses. Thanks to the stateful services, it reduces the latency levels. For programmers, it gives the flexibility of choosing a language, choosing a framework. The deployments are much quicker, and you can actually deploy your application to any cloud of your choice. The administrators get a great insight into the health of the system, and these microservices applications are actually self-healing in a way that Service Fabric reduces the time taken from the failure to the recovery of a service. The upgrades are coordinated. What that means is basically if you are upgrading a particular application on a Service Fabric cluster, you do not have to disturb any other application. So everything goes on fine, and the upgrades can happen in parallel, which is a great feature. Okay, so Service Fabric is not really a brand new platform, even though we've been hearing it for last year or two. Microsoft has been using Service Fabric to power many of its cloud-based services, and some of the popular names you can see on the screen. Okay, so let's take a look at the demo for today. Well, we do not have a lot of time, but I will tell you how we could create a Service Fabric application in Visual Studio. So you go to New and Project, and you select the template for cloud, and you see a Service Fabric application as new template. For this, you need to install the Service Fabric SDK, of course, that you can get online. And once you created the application, as you can see, it creates a Service Fabric application with an application package root, which contains the application manifest, with the one we just saw. And if you see here, it specifies the services that the application contains and some other parameters which are important for the application. One other thing to notice here is the publish profiles and application parameters. So you see two files here, local.xml and cloud.xml. Local.xml specifies the properties for your local deployment, whereas the cloud.xml specifies the connection parameters for your cloud deployment. So that are the main folders that you'll get by default. And then you can add a stateful or a stateless service to a service app application by going here, and it actually gives you 4 options: stateless service, stateful service, actor service, and stateless web API. So if you see any of the services, in this case I am looking at a stateful service which has a package root in itself, which has a config folder where you specify the config package, and then you have the service manifest, which again, as we saw in this, one of the slides, contains the endpoints, the entry point, and the entry point and setup entry point and various other parameters. So once you build your services and you deploy locally using the option deploy solution, and I'm skipping that part because I've already brought up, once you deploy, it brings up a Service Fabric Explorer. This is where you could actually monitor your application. It brings up a dashboard which tells you that you have these many applications, these many nodes, and then for each of the nodes, it tells you various details like health of the node, is it up or down, are there any errors, and stuff like that. You could get more and more details. It actually gives you a cluster map and various other information. So a similar thing you will find when you go actually deploy to production. I haven't kept that ready yet, but you can actually go and create a Service Fabric cluster in your production environment and specify all the properties and everything and just manage your application in a similar way. So with that, I'm at the end of my presentation, and Noor, you can take over from here.
Thanks, Viplav. Thanks for the quick session as well as quick demo. Yes, we have a couple of more minutes, so I would like to take maybe 2 to 3 questions from the audience. The first question is, how is Service Fabric different than the cloud service that we have been using so far?
Yeah, so Service Fabric is different because there's one key difference between the two, and that is like whenever we are deploying a cloud service, you are actually you're deploying it as VM, because let's say you have a web role and a worker role in a cloud service app. Essentially, you also specify the VM configuration settings when you in your application. So what I'm trying to say is that they are very much tightly coupled with the VM, and it's the application is, as I said, very much tightly coupled. But in case of Service Fabric, that's not the case. You build the services with you're completely agnostic to the fact that what is the infrastructure underlying the service, because as we learned, you could build the service and deploy to any of the clouds, any type of machine, and that's the key difference between the two, cloud service and Service Fabric. And one more thing I could think of is that Service Fabric, you can have more than one application on one VM, which I believe may not be possible in case of cloud-based service.
Okay, thanks, Viplav. So the question is, what criteria should we consider to pick between reliable services or reliable actor programming models?
Well, the answer is just like for any other design pattern, right? Reliable actor model is based on the actor design pattern, and just like any other design pattern does not fit all the scenarios. You have to see what your scenario is. If your application can be split into a number of independently running units of compute and logic, then well, yes, reliable actor is a great model. But if not, if you have to maintain the state across the units, across the application, then you should go for reliable services model.
Thanks, Viplav. I know we are almost running out of the time. I have a couple of more questions, but what I would like to do is, in the interest of time, we would like to take those questions offline. With that, I would like to thank everyone for taking time to join this webinar, and I hope you found it informative. As you can, Vipula, if you could just move to the next screen, I would just like to highlight our next webinar, which is on Jan 22nd at 9 a.m. Pacific time, which is on Azure ARM templates. So I look forward you joining to this webinar as well. Thanks and have a good day. Thanks, Vipula, for the wonderful session.
Thank you. Thanks, everyone.